Good morning, good afternoon, good evening, if anyone out there it's evening, um, that you should go to bed. I guess, yeah, features, performance, scale, virtual firewalls. Obviously, that covers quite a lot of ground. So let's, put some definitions. I'll start with the last one first, scale. What do we mean by scale? The scales of justice or fish scales or the sound of music. No, we're talking about how we optimize compute, right? And that's the reason that we want to optimize compute in terms of network security is, for the efficient use of resources. And, we have certain resources available to us, whether that's, in our private cloud environments. We've got, so many CPUs, so much memory, or in the public cloud environments. And, they can get expensive if we don't efficiently scale, efficiently use bandwidth, efficiently apply licenses, or if we've got oversized or unnecessary instances and compute just laying around, we're not using our money wisely, right? So that's what we mean by scale. There's really, I guess, two main ways that we can scale when we're talking about virtual firewalls or VM series firewalls or CN series firewalls. The two methods we have are to scale up or scale down, or to scale in and scale out. So, what we mean by scaling up, right, is by applying, more compute to a single instance, applying more memory to a single instance. And, that can find us with performance gains with throughput, support for more objects, more rules, support for more concurrent sessions, etc. And scaling out, is essentially just, modifying the number of instances that we have available to handle sessions and throughput. So, those are not mutually exclusive. We can scale up, down, and scale in, out. But how we achieve that and how we scale up and down and in and out, we do that in different ways, right? So I'll start by talking a little bit about scaling up and down and some of the advantages and disadvantages of that. Purely from a licensing perspective, scaling up just requires that you go to the support portal and change the number of vCPUs that you want to use for a given instance. Obviously, this is very easy. It's simple. It doesn't require panorama or any orchestration, but it does require that you make the change from a licensing perspective in the support portal as step one. And then it requires that you go to, whatever hypervisor or whatever system or cloud where this virtual machine exists. You shut that virtual machine down, and then you change the resources. You change the number of vCPUs and memory to match what you set up in the deployment profile from the licensing perspective. This is good from a scale perspective because it doesn't require any architectural changes, but it is, a fairly manual process. There's, some automation that you could apply to it, but for the most part, there's some manual steps. And of course, we support anywhere from, 2 vCPUs all the way up to 32 vCPUs. And, we'll talk about, the performance that, you can expect to see as you increase vCPUs. And of course, that's very much going to depend on the environment or the hypervisor that you're running that virtual firewall on. When we talk about scaling out or scaling in, we're usually talking about doing this in a more programmatic way. Auto scaling, right, is a popular term, and something that probably more popular of an idea in the public cloud. Things that we do in AWS or Azure or GCP. But it's certainly not limited to that. And there's certainly, I've worked with a number of customers that even in their private cloud environments have moved away from, hardware firewalls in favor of load balancers and software firewalls. Customers that, just want to create large compute clusters and remember back to the slide with the money on it, efficiently use the resources and the compute that they've invested in. However, to do scaling in and out is a little bit more complex than to scale up and down. It requires that you are collecting metrics about those virtual machines so that you know when you need to scale. It requires usually, some type of automation. It can be based off of timing, right? It can be based off of the current load that the firewalls are under. But you've got some event-based mechanism that is making a decision about when to add a firewall or firewalls and when to remove firewalls so that you can free up resources, for other systems. So some organizations will take a look at, they've got fairly, static use of a given application throughout the day. They may, base that off of a schedule. So they may scale up the number of firewalls that they have based on their historical information about usage of applications. Whereas others, it may be dynamic. You don't really know when you're going to get a surge of customers or users using applications. And in that case, you need a mechanism through the collection of those metrics to kick off an event to, spin up a firewall or spin down a firewall. The drawbacks here are, that the customization required, and we do have, templates out there, and we have, Terraform templates, and we have templates for public clouds like CloudFormation for AWS or ARM templates for Azure. But those are examples, right? And customers need to take those examples and essentially, use those examples and formulate them for their own environment, which means that, the end user and the customer has to maintain that customization and has to support that customization, right? That's not something that you can call into support for code that you've built. So, those are the downsides of it. And so, that cost optimization aspect, you just really kind of have to ask yourself, is it worth it? Or, do I just create the capability of, the high watermark, if you will, of the applications that I need to firewall? And just, even have, firewalls that sit out there that are consuming compute, even though, I may not need to use all that compute. It's certainly more expensive, but it doesn't require those moving parts and that customization. So if you've ever, looked at auto scaling templates, if you go to GitHub, it looks like this, right? It looks like it's, well planned out and well thought out. And we've got these great examples out there, and you can just templatize them. But, if you've ever tried to implement them, then, this might be you. They're complex, and it's not easy, and it's not simple. And as I mentioned, it's, you're kind of on your own from a support perspective. So that's, what we've tried to address recently with a feature we call panorama orchestrated templates. So we've tried to take, those templates that we've had that have been community and end user supported, and pull those into Panorama and extend Panorama's plugin infrastructure, and essentially create the cloud components necessary to build the automation and the metrics collection for you, and do all that directly within Panorama from a plugin. Obviously, there are some dependencies for this. And today we've got Panorama orchestrated templates, both for Azure as well as for AWS. And I've got some news coming about GCP, but today it's Azure and AWS. So, to understand these, you have to look at the reference architectures that we've put out there for customers for how we recommend deploying firewalls within a given public cloud environment. Specifically with Azure, the transit VNet model reference architecture. It's a model that separates ingress versus outbound and east-west flows. And it's a model that scales to support, any number of applications that, you want to host within your Azure environment. This is a model that, we have, very well-published documentation on this. And many customers have implemented this model. So what we've tried to do is, with this in particular, is take that transit VNet model and create a panorama orchestration for it. So the panorama orchestration will create all of these pieces, all of the VNets, all of the UDRs. We'll create all of the permissions necessary, and we'll deploy the firewalls, and we'll also track metrics and scale the firewalls automatically based off of the current utilization. So it's the transit VNet model is essentially broken out into two different templates, two different panorama orchestrated templates, one being the inbound stack, which is purely for handling applications that are accessible from the internet, and the hub stack model, which handles both east-west and outbound traffic. So, if you look at the reference architecture for transit VNet model and the panorama orchestrated templates for hub stack and inbound stack, and put those together, you'll see an overlay and symmetry between them. With AWS, the model that we've chosen to replicate is the centralized design. So again, another highly published and reference architecture is the centralized design. It's incredibly scalable. It handles very large numbers of VPCs, and it supports the ability to inspect ingress traffic, pardon me, egress traffic, as well as east-west traffic. And I've got links to where you can go and look at the reference architecture documentation for this model. But of course, we've taken that and moved that into a panorama orchestrated template. And it will go and create, of course, all the security groups necessary. It will go and create the routing tables necessary. It will create the VPCs. And it will do this across multiple availability zones. By default, it'll create this across 3 different availability zones. So all the pieces and all the components for the centralized design get created by the Panorama orchestrated template, except for the transit gateway itself. The transit gateway must be manually created. And there's reasons for that, that we've got documented if you care to go into that. But the Panorama orchestrated model makes it much simpler. And of course, it's supported, right? So any problems rolling that out, you can certainly pick up the phone, and support is there to help, which is, I think, a major leap forward with what we're able to do with scale out, scale in within the public cloud. Switching gears, no pun intended. Want to talk a little bit about some of the performance considerations with VM series, and there are a number. I've mainly focused, I think, on public cloud with this discussion so far, but I want to talk a little bit about private cloud and some of the things that we see customers sometimes run into are different bottlenecks, right? When you have a virtual firewall and it's running on a hypervisor, that's great. But if that same hypervisor is hosting 50 other virtual machines, well, you can't expect to get the performance that we advertise. So customers, I think, especially customers that have come from hardware firewalls and have looked and trusted our data sheet numbers and our spec sheet numbers and the throughput that we advertise for our hardware firewalls, moving to the virtual firewalls sometimes don't understand the things that can happen that can affect those numbers, right? We publish those numbers, but those numbers are dependent upon certain factors. And there's really two main places where we see bottlenecks and things that prevent optimal performance around the VM series, and certainly one of those is at the network. So I want to take a little bit of time just to talk about different models where you can connect the physical network to the virtual firewall. The first is with PCI pass-through. PCI pass-through is essentially taking the virtual network interface from the virtual firewall and assigning it to a physical port on the host. So this is obviously going to eat up ports on the host, and is something that will limit the number of virtual machines that you can even host on this particular hypervisor, right? But it is something that if you're looking to get the optimal performance with no potential network bottleneck, then PCI pass-through is the right choice. And perhaps you're even only running a VM series firewall on this one particular host, then PCI pass-through is the choice. But the next best thing is something we call SRIOV, or single root IOV, which takes that physical network interface and kind of divvies it up into virtual functions or virtual queues, if you will. And this accomplishes two things. One, it creates a link between the virtual firewall and the physical network device that's hosting that virtual machine. And it also bypasses kernel space. And that's very important because if you're not bypassing kernel space, then when a packet enters the physical port, it needs to be copied into kernel space. And of course, the virtual firewall runs in user space. So that same packet then has to be copied into the user space. So this, of course, creates some inefficiencies, and, you can certainly run into bottlenecks where the network is preventing the virtual machine from, getting the optimal performance based on the number of vCPUs that you've assigned to it. Yet another option is DPDK. And this is something that is gaining a lot of traction in a lot of environments. It doesn't require that you have as many changes in the kernel itself, meaning you don't have to make as many fundamental changes to the hypervisor upon like boot up of the hypervisor. This is something you can do with the running hypervisor, running system. But it requires that you, at least, in the world of KVM, it requires that you compile Open vSwitch with DPDK enabled. The same would be true with ESXi. You just need to enable the virtual switch with DPDK. And then you also need to take a look at some of our documentation, as well as the hypervisor documentation, and potentially match the DPDK version, or make sure that there's compatibility between the DPDK versions running in the virtual switch and what we're loading within the virtual firewall that you're installing. Now, this is something that from the Palo Alto virtual firewall that you can modify through the VM series plugin. So you can upgrade or downgrade your DPDK version through just, by using the plugin model, not in Panorama, but on the virtual firewall itself. And of course, these are all things that can be configured as part of bootstrapping and the bootstrap process, so that, once you've created the optimal configuration from a networking perspective, with jumbo frames, potentially with DPDK or SRIOV, you can save those settings, of course, in the bootstrap file that you pair with the virtual firewall that you're rolling out, and make it all automated. The other type of bottlenecks will be, bottlenecks more from the processing perspective. So this is where we talk about, something called NUMA, or non-uniform memory access. And, as we deal with more and more cores, sometimes, we kind of forget to think about the sockets that these cores are being plugged into, and the memory that they have associated with them. And what that means is that, in this example, I've got, 16 cores across 2 different sockets. So these 2 different sockets have their own memory available to them. So non-uniform memory access means that, these 8 cores have access to this memory, and they don't have access to this memory. And so, while I might assign 16 core vCPUs to a virtual firewall, I'm not going to get the same performance out of 2 8-core sockets that I will out of a single 16-core socket, because I'm not using non-uniform memory access at that point, right? So as soon as I scale in this model, as soon as I scale beyond 8, now I'm not in NUMA mode anymore, and that creates some inefficiencies. So understanding your cores and your sockets is very important in terms of being, predictive about the performance that you expect to get from the virtual firewall. In terms of the features that support this, you can certainly change the number of vCPUs that you have assigned to either the management plane or the data plane. When you create a 4 vCPU firewall, by default, one of those vCPUs will be assigned to the management plane, and 3 will be assigned to the data plane. You probably wouldn't do this for performance reasons, but you can absolutely change that and make 2 vCPUs assigned to management and 2 to data plane. Where we more often than not, where we see this is when we get into 16 or 18 or 22 or 32 vCPUs. Those come with a certain number of management plane vCPUs by default. So, if you're dealing with those, large number of vCPUs, a lot of times it makes sense to reallocate the CPUs that you have available to the management plane versus the data plane. The trade-off being you may have longer commit times, right, with less management plane vCPUs, but you may be able to support more throughput or handle more sessions with more data plane vCPUs. But that is fully customizable, and since PAN-OS 10.1, and I find that a lot of customers are unaware of the fact that they can affect the number of vCPUs assigned to the management plane and data plane. And all of this boils down to what we generally care about, which is throughput and compatibility. And I'll just warn you, like I've compiled this information, and it's all based on 64K HTTP transactions, and I've rounded some of this data, and I've taken this data from different performance tests ranging from PAN-OS 9.1 to 10.2. So, keep that in mind. This is meant to be more of, I guess, an example of sort of the differences of what you can expect between, pure SRIOV versus DPDK versus packet mmap. And I don't think I mentioned this, but the firewalls by default will try to negotiate DPDK with its virtual switch partner. And if it fails, it will fail back into packet mmap mode. Whereas I described, that packet gets copied, from the NIC into the kernel, and then copied again from the kernel into user space. And you can see there's a pretty significant drop in performance, especially as you start adding large numbers of vCPUs. Where we have a direct line from the network to the cores, there's obviously massive performance gains by not having those extra steps and not involving the kernel in the process of getting the packets from the NIC to the firewall. DPDK, very similar to SRIOV, not quite the performance, but almost, and again, not something that requires as much upfront kernel configuration of the hypervisor, but packet mmap mode, which would be the least desirable of these 3 modes with VM series, obviously going to take the biggest hit from a performance perspective because of those inefficiencies that I talked about. I did mention we do scale up to 32 vCPUs. Just of note, the performance numbers that I got for 32 vCPUs, those were done with 2 16 vCPU cores, right? So go back to your notes on NUMA, right? 2 different sockets with 16 vCPUs each. Another feature and capability that a number of customers have taken advantage of is a feature called intelligent traffic offload. And this is something that's native really to the hardware firewalls. The hardware firewalls have we call it the Tiger chip, but there's essentially the ability to maintain a session table at the network interface level, so that not everything has to go round trip through the CPU. And so we've essentially tried to replicate that with the VM series, and doing that with DPUs or network cards that are capable of maintaining that state table. So the Bluefield 2 DPU SmartNIC is currently the chip that handles this, but there's more SmartNICs becoming available on the market, and I suspect that as those become available, we'll continue to try to develop support for it. But it's essentially a notification process via gRPC that PAN-OS will send to the GPU, telling the GPU that for these flows, I don't need you to send me any more traffic. I've identified the application. I know what the application is. I don't need to do any further IPS inspection or anything that needs to run through signatures. Think SSH or even SSL if you're not decrypting it, right? I'm good. I don't need any more packets, and those packets can just essentially hit the NIC, the smart NIC, and turn around and be forwarded on without any involvement from the kernel or the virtual firewall at all. It does require a license, and it does require very specific network cards. So it's something that has to be architected, right? Just taking another kind of look at this, the packet comes in, hits the flow table. The flow will be recorded by the smart NIC, assuming it passes through the virtual wire policy and the traffic is allowed. Then the data plane via gRPC will send that notification over to the RPC server on the smart NIC, just notifying it that future flows can just be handled directly by the smart NIC, and the firewall doesn't need to be involved. All right, so moving on to, I guess, the last portion of this presentation, I thought it would be, you guys probably want to know what's coming. I do have to, throw up this disclaimer. This might change. These are not guaranteed things. So don't be mad at me if some of the things that we talk about from this point forward don't end up coming out in the next version. So obviously, one of the things that we want to do is to be able to use cloud managed Panorama to manage on-premise firewalls. And that, of course, is not only limited to VM series, but also to hardware firewalls as well. So, we want a single pane of glass with this, from a cloud managed solution. And, this is going to be based on the same credit model that the VM Flex is based off of. To do that, we'll have to, figure out how the plugin, the Panorama plugin functionality is going to be replicated, right? Today we have these plugins that are very powerful that allow us to collect dynamic address group information from things like ACI or from NSXT or from Azure or from AWS, and allow us to create dynamic groups based on that. So for the public cloud, that model will essentially move to the cloud identity engine. So we'll move the plugins that collect that, both the user ID and the user information or the user authentication that cloud identity engine already handles, whether it's SAML authentication or whether it's integrating with your on-premise Active Directory or Azure Active Directory to collect IP to user information. We'll just extend the plugins that we have in Panorama that collect dynamic address group information from Kubernetes and from GCP. We'll move that functionality into the cloud identity engine. So effectively everything can be managed from Panorama as a service. Additionally, and I told you, there was a solution. I guess this sort of kind of completes the trifecta of the big three clouds in terms of what we plan to do with scale and delivering those panorama orchestrated templates will be to integrate with Google's 3P integration manager. This is kind of a new concept for Google and GCP. But it's their method of allowing third-party integration tools to integrate with their cloud native tools. So this will be a scalable model, very similar to what we talked about earlier with both Azure and AWS, and being able to scale multiple virtual firewalls and collect metrics and create events, time-based events or event-driven events based on performance requirements for that auto scale out and scale in, and trying to deliver that in a way that's easy to consume for you guys and gals. We also plan to sort of complete the capabilities of products that and services that we deliver on both the VM series and CN series that we do on the hardware firewall, specifically support for IoT, SaaS inline, AI ops, machine learning, etc. So complete feature parity between all of the platforms, hardware, VM series, and containerized firewalls. Also plan to continue to make VM series more compatible with the market tools out there that are making compute even easier to consume for customers and less expensive. So I don't know if you guys have looked at Ampere or looked at the Tau computing engine or any of these new the Gravitron processors, but essentially they're just more compute for less cost. And so it is a RISC-based architecture. So it's kind of a move away from the Intel-based chip processing. So it requires, some development work to be able to support these different chipsets and these RISC, ASICs really. But there are huge benefit in terms of performance and cost associated. So private clouds, you'll see, if you haven't researched Ampere, go out and take a look at those guys. They're doing some really exciting things and delivering some really amazing hardware with really impressive performance at very reasonable prices. And of course, the same concepts apply in the public cloud. So, support for those. We also plan to support link aggregation. So, being able to, again, create that feature parity that we have between the hardware firewalls and the software firewalls. So this, will allow us to, comply to IEEE 802.1ax link ag support, and allow us to, increase bandwidth between peers and load balance traffic, across the combined interfaces. As we, move to 32 vCPUs and 64 vCPUs and eventually, 128 vCPU virtual firewalls, as we're supporting, virtual firewalls that can do 20, 30, 40 gigs of throughput. Obviously, we need to be able to do link aggregation across 40 gig and 100 gig links to support that throughput. Additionally, we kind of talked about the Bluefield 2, GPUs and the capabilities of ITO or intelligent traffic offload. Azure has, the plans to roll out what they call their, MANA interface, which, is just really those Mellanox NICs. So, we have, planned support to support their Azure specific implementation so that we can utilize intelligent traffic offload specifically within the public cloud environment. Today it really is only a private cloud tool that at our disposal. And then probably the one that I'm at least the most excited about is session resiliency for VM series cluster. We have the ability to do clustering today, but it's only supported in the private cloud because you need layer 2 connectivity across all the firewalls to be able to share those state tables. So the general idea here really is that we can do active passive HA, but that doesn't really scale in the public cloud. And if we've got multiple virtual firewalls behind a load balancer, while that scales, if you remove a firewall, which firewall handles the sessions from the firewall that you removed, right? Now those sessions have to be reestablished today, so that can impact the user experience. So this feature will add a common Redis database that will sync sessions across all firewalls in a given auto scaling group. So a welcome session or a welcome feature that I know we've been looking for quite a while. So very excited to see this on the list and see this coming in the near future to support a better user experience and much faster session failover. Some helpful links here. I think Katie mentioned that you should share the presentation with you guys. These are hyperlinks, so these will take you to be able to read about some of the things in more detail that I talked about today. And I certainly plan to take anything that you guys submit in the Q&A and respond to it. And get back with you. And outside of that, feel free to even, just to email me. You can get me at jhillen at paloaltonetworks.com. So enjoyed speaking with you guys today. Hope some of this was helpful and maybe even a little bit entertaining. And with that, Katie, I'll hand it back to you.
Thanks, Jeff. It looks like there are 2 questions in the Q&A if you want to take a look at those and see if you can answer those. We do have a little bit of time before our next session.
Great. So we've got the PA VM series supported in Azure Gov. I'll need to get back with you. I have not looked specifically into Azure Gov, but I'll find out and let you know, David. And let's see, we'd love to hear more about Strata Cloud Manager. Yeah. So, I don't know if you've gone to, hub.paloaltonetworks.com, but that's where, things like AI ops are managed. Any of our cloud-based tools are out there. Today, Prisma Access is managed either through Panorama or the cloud managed Panorama. So that's kind of what we're talking about, is taking that cloud managed Panorama and extending it not to just be able to manage Prisma Access, but also to be able to manage on-prem firewalls. So there's a lot of work to be done there. As I mentioned, you've got the plugin model to move to the cloud identity engine. But there's certainly going to be, a lot of information coming down about that. And again, you can go and test out and play with the cloud manager today by managing, Prisma Access. So you can talk to your local account teams about, getting evaluations and that type of thing set up. You can get in and play with that and mess with it today. Oh, IPv6 support for public cloud. Yeah. It depends on the public cloud. And it's, very high on the roadmap. I didn't talk about it, but it's you'll see it very soon. I can't promise across the big 3 clouds that it will be the next release. But I know that, there's some information coming there.
All right, great. Thanks so much, Jeff.